All right. On our Algebra 2 review, this first part is going to be just the first 1 to 11. The question here, and I had changed up the directions for 1 through 5. It was for every one of these, decide whether it's a polynomial, write it in standard form, state its degree, actually even took off type because many of them don't have any, leading coefficient, and give the end behavior. So for number 1, this is a polynomial, and since it is a polynomial, I'm going to write it in standard form. And standard form is when we take our polynomial and have it ordered so our term with the highest exponent is in the lead. My exponents were 7, 3, and 2, so I'm going to come down in descending order of exponents. There's my standard form. Once I've got standard form on there, it's easy to see that the degree is the highest exponent, which is 7. That's an odd number. That matters in a minute for end behavior. The leading coefficient is negative 15. That's a negative number. That matters for end behavior. So for end behavior, if this is an odd negative, I got to stop and think about this here, but odd negative starts up high and goes down low. And so then when you're describing end behavior for odd negative, on the left-hand side, f of x approaches positive infinity as x is going to negative infinity, which x is always doing on the left. And then on the right-hand side, f of x is approaching negative infinity as x is approaching negative infinity, which x always does on the right. I'm sorry, positive infinity, which x always does on the right-hand side. So my end behaviors are right here next to my sketch. In problem number 2, this is not a polynomial. Polynomials can't have polynomials need whole number exponents. This fraction is what violates the issue there. Nothing to do with that one besides say why. Then going down to number 3, my exponents, this is a polynomial, so I get to put it in standard form and rearrange it. Highest, so h of x is going to be, I'm starting with the 6x to the 5th plus x squared minus 5. My degree is 5. That's an odd number. My leading coefficient is 6. That's a positive number. Degrees are always odd or even. And leading coefficients positive or negative. Odd function positive acts like this. It goes up. There we go. And then for end behavior, f of x on the left side is going down, as on the left side x values are always going down. On the right-hand side, f of x values are going up, as on the right-hand side, x is always going up. Now move into number 4. It's a polynomial. It's already in standard form, descending order. Standard form is set. Nothing to do there. Degree is 4. That's even. Leading coefficient is 3. That's positive. And even positive, I always relate back to that idea of our parabolas. I know with a 4th degree there'd be some wiggles down here at the bottom, but the idea of end behavior is still the same. On the left, f of x is going up. As x is going down, x always goes down on the left. On the right, f of x is going up as x is going up, as it always does on the right. Last but not least in this crowd, if you guys had to do the type, it's not on the test, but that last one would have been quartic. The one before quadratic, this would be a quartic. This is already in standard form. I'm good to go there. Highest exponent and going down in descending order. Degree is 4. Leading coefficient is negative 1. Right here, we got to think about that as negative 1. That's an even degree. Negative leading coefficient. That's going to be matched up with those parabolas, those quadratics that go down. And so for end behavior, f of x goes to negative infinity as x goes to negative infinity, always on the left. F of x on the right goes to negative infinity as x goes to positive infinity, which it always does on the right. So hopefully we've got some of those misconceptions or any little tweaks you got to do on that figured out for the test tomorrow. The first thing on your test is the fill-in-the-blank end behavior chart. So that end behavior chart, like many of you guys already aced it. It's just the first thing you run into on the test is to fill it in. It's fill in the blanks, just like you saw on the colored paper in class. When we go to the next, when we go to, show you, see? First part of the test. There it is. Fill in the blanks. Okay? That's the top of the test. And then if you got it right, it's there for you to use. Numbers 6, 7, and 8, I think the directions were just find the sum or difference. Now with number 6, I noticed that this is a difference, and I've talked about finding differences different ways with different people. I've taught this different strategies, but I'm going to go back to my original strategy. Whenever it's a minus sign, we always have to act like this is subtracting, and this is like multiplying through the parentheses by -1. On this first term, I can just come over and just ignore the parentheses, make them go bye-bye. There's nothing out in front that needs going to change any signs. -1 times -8x squared is going to turn that to add 8x squared. -1 times adding 4x is going to turn that to subtracting 4x. -1 times adding 3 is going to turn that to subtracting 3. And then it's a matter of going through and adding up your like terms. Your 4x to the third, there's nothing else like it. When I start putting together my x squareds, I've got -12 of them and 8 of them, so that's going to be -4x squared. Got those out of there. Only one term has an x, that -4x. And then my constant, -5 minus 3 minus 8. Final answer for that one. These do not get done without showing some kind of work. Number 7's a little bit easier because it's just adding like terms, and I can just ignore parentheses or just kind of do what I'm doing here, cross them off or erase them, because there's nothing being multiplied through. So now it's just adding like terms. X to the 4th and 2x to the 4th is going to be 3x to the 4th. I start going descending order because it just kind of helps. 3x to the 3rd. There's no other x to the 3rd terms. I got a -x squared. There's nothing else with an x squared on it. I got a -3x. There's nothing else with an x on it. And then 6 and 9 together are going to give me a 15. So far, so good. Nick, a couple of people, catch me if anything's Sade. Put a star by it, sweetie. I'm going to come back to you. Just because I'm putting this in a video, okay? So, yep, you guys, if there's something that you want me to look at with you, I can do that. Just put a star next to it, and after the video, I'll do it. All right, so in this one, I'm going right back to the strategy I used up top for number 6. I can get rid of those parentheses in the first group. Nothing's being multiplied out front. And then I have to distribute my -1. -1 times a positive x squared turns it into -x squared. -1 times subtracting 2 turns it into adding 2x. Subtracting 2x, adding 2x. -1 times positive 12 or adding 12 turns into subtracting 12. And then I'm just adding up like terms again. I got 3x squared minus an x squared. That's going to be a 2x squared. I got a 9x and a 2x. That's going to be an 11x. And I got a 13 minus 12. That's going to be a 1. Now I'm going to say this again. Anybody watching this is like, holy cow, that woman is going so fast. This should just be checking work. There's been 3 days in class, shoot, even yesterday, 3.5 days of class that you guys have had time to work on this. So somebody watching it would be like, yeah, that's quick. Well, there's the reason. Numbers 9, 10, and 11, I even got myself set up for some of these multiplications. Like, I just like to continue to use the box method. I haven't had anybody really approach me with any kind of other extended distributive strategy. I think you guys have picked up on using this. I actually was teaching this to my daughter, Sadie, and she's taking Algebra 1 right now. And her teacher didn't show her this method, and she's like, oh, that's really easy. Her teacher's a first-year teacher. Nothing wrong with that, but they don't have all the methods. Nothing wrong with that, but they just don't know all the methods, so... Oh, I don't know. So the comment was, I wish my mom was a math teacher growing up. Yeah, that's probably not the case if it actually was you. I am the last person that Sadie wants help from, because she is like, you teach Algebra 2. You can talk over my head. No, but she knows. When she's getting ready for a test and stuff, she'll let me. Now I'm going to add like terms to pull these out. When Sadie's getting ready for a test and whatnot, she will come to me with questions because she knows from past stuff that, now I'm losing my train of thought here. She knows from stuff in the past that I've helped her kind of at the end game just to make sure she's not missing anything. 12y's minus 7y's is going to give me a 5y. Talking too much here. So when I pulled everything out, I got 2y to the third plus 10y squared plus 5y minus 21. So as you guys are looking at this last one, so this week was interesting because she was been out of shape, irritated with kids in her class. They had an open notes quiz. She's like, I got 100. Why wouldn't you get 100 if you're using your notes? And I went, good point. Not everybody thinks that way, but that's my kid. So why wouldn't you if you got notes? But she's really, you guys, of course she's gifted at math, my goodness. And I think it's nearly only just because we talked about math so much when she was little. Anyhow, just number stuff, you know? Yeah, no, yeah. We had like, no, but like, you know, being math teachers, we know about how to talk about number concepts with little kids to introduce stuff young. But. Now, first box, when I multiply 2m by 2m, 4m squared. 2m times n is 2mn. A lot of people that were sitting down and really putting in the time on these were like, had questions about these when I've got these letters next to each other. Now, 2m times n is going to give me another 2mn. N times n is going to give me n squared. Now, whenever we have groups of 3 like this, we go and figure out what's the product of the first two. Well, that was 4m squared plus 4mn. Plus n squared. Now I've got to go multiply that by the last 2m plus n term. So once I've got my answer for the product of the two, I've got to multiply by my last 2mn term. And I'm just going to tell you guys sitting here in 5th hour, the video is so much more crisp to watch than what you're seeing just on my screen in class. Like you can see the colors and everything in the video. My Elmo and my projector are like on their last legs, and it's just not real cool in class. When I multiply these through and fill in the boxes, upper left I get 8m to the third, 2m times 4mn, 8m squared n, and in the last box, 2mn squared. This is kind of a trick for some of you guys just looking at it. It's m times m, so I've got to make sure the square is on my m this time. And like over here, you can see the square's on the n because it was 2m times n squared. So down here, 4m squared n, 4m n squared, and then this bottom right is n to the third. And so then, when I go to get to a final answer here, I'm going to just start pulling out like terms. And pulling out like terms, I've got 8m to the third, and I've got some like terms that are in diagonals. I got 4 of these m squared n's and 8 more of those m squared n's. There's 12 m squared n's. I got 4 of these mn squareds and 2 more of the mn squareds. So that is 6mn squared. And then in this other corner, I got this n to the third. Not you. Wouldn't that go to the what? Sorry. Wouldn't that go to the what? Ah, I like how you're thinking. We actually, when we have 2 variables in there, we kind of... Faith was asking, wouldn't I move my n to the third to the front? It actually, we kind of work in. Like, so if we've got the highest power of m and then we start mixing these n's, the n to the third n squared n kind of comes in from the going in on the left. Does that make sense? Okay. We're doing math. Okay, just want to make sure. Now, number 11, same idea. We got s plus 2 and s plus 4. We got to go multiply those through first. That's going to give me an s squared, a 2s, a 4s, and an 8. Thankfully, some of these are easy. So then this product is going to be s squared plus 6s plus 8. And then I have to go multiply that by that s minus 3. So s minus 3 is going to come here. And then my s squared, 6s, and 8 come up here. And then as I'm filling in boxes, I got s to the third, 6s to the second, and 8s. I got negative 3s squared, negative 18 s's, and negative 24. when I want to go pull these out to answer, I start gathering like terms. I've got s to the third. There's not another one. So 6s squared minus 3s squared is going to give me 3s squared. Negative 18s's plus 8s's is going to give me negative 10s's. And then that bottom right corner minus 24 is going to finish me off. Now, expect to be performing types of these. You guys, the test, you complete and fill in your end behavior chart. Then you have to go determine end behavior of specific functions. You go through that whole, is it a function? If so, put it in standard form. If not, explain why. We're actually down to the fourth bullet of our test items that are on the backboard. Find the following for polynomials. We just did sum, difference, and product. So what we have left now is quote.